Before anything else, thank you. This channel just passed a number I genuinely did not expect. And since everything in Krill is a node with a value, let's count it the only way this channel knows how. 1,000 subscribers. 1,000 people who believe that your automation and now your AI should run on hardware you own. This one's for you, and it's the biggest thing we've built yet. So here's what we're going to do. In this video, we're going to show you how to privately and securely connect every locally hosted LLM that you and your colleagues have available and divide the work between them. Krill chooses the best model with the cheapest cost to run based on data points you set, like your local energy prices. Now, let's consider a hypothetical college with campuses around the world. It's full of students and faculty running local LLMs, all with different capabilities. There could be hundreds of them. For this demo, let's look at a small number. So, how many computers on your network are running an LLM right now? A workstation here, a lab box there, a dorm rig that only earns its keep after midnight, a cluster node somebody spun up for one project and never turned off. How many of them are idle this exact second? Most of them, and everyone is a machine you have already paid for. Here's the question nobody asks. What does that compute actually cost you to run? Because a watt at noon is not a watt at midnight, and a solar panel in California is nothing like a tariff meter in Mumbai. Here's the answer Krill gives. 4 machines that have already found each other. Nobody configured that. 3 campuses with different sized computers running local LLMs. Some are a small model on an idle laptop. Others are powerful dedicated servers with massive amounts of VRAM, also going unused at times of the day when power is cheap. And then the library. That last one is where you are, ready to kick off an overnight job that will use your fleet of LLMs wherever it is most cost-effective. Berkeley, Mumbai, Boston, and the library. 1 swarm, 3 time zones. Berkeley first. The campus runs on solar, so we give it a light sensor, a data point reading lux off the panels. A calculation turns sunshine into a price. The brighter the panels, the cheaper the compute. Free energy should mean nearly free inference. And a daylight flag on a daily timer. At dusk, it flips off, and this campus simply stops advertising. No sun, no cheap watts, no point. Now the campus GPU itself. Its advertised cost comes from the solar calculation. Its accept window comes from the daylight flag. This is the new part, an LLM that prices itself off the real world. It's mid-morning in California, the panels are bright, and the flag is up. And to be clear about what this is, these machines are not on some public GPU marketplace. They belong to you and your colleagues, deliberately and securely added to a private swarm with a shared derived pin. Nothing here leaves your network. Mumbai plays by different rules. Daytime energy carries a tariff there, so we feed the live tariff rate straight in as a data point. And Mumbai is the monster of this fleet, a 235 billion parameter model on a 1/4 terabyte of VRAM. It is genuinely tantalizing to send everything there. But it advertises that tariff as its cost, and for most of these jobs, the others can do the same work cheaper, so it waits for the work that actually needs it. Boston prices itself off the New England spot market, the real-time number the grid operator publishes. And this is how it gets there. A webhook wired to that price, calling the ISO's API every time the market moves. That's a real HTTP request leaving the node, not a number we typed in. Its GPU re-advertises that price as its cost to run. 3 campuses, 3 pricing strategies, sun, tariffs at the spot market. Now watch this. 1 toggle and the swarm reshapes itself into a trading floor. Every machine, every LLM it is offering and nothing else. So let's put it to work. This is where you are. And you kick off a job. Summarize the campus energy posture. It lands right there on the canvas, attached to the machine that asked. A 5-second claim window opens and every eligible node bids its current price. The window closes and Berkeley takes it. Solar at mid-morning beats the spot market and crushes the tariff. And notice the big Mumbai model did not win because nothing about this job needed it. And seconds later, the answer lands back where you started. Nobody chose that machine. Nobody load balanced anything. The prices did. Now the finale. The Chancellor wants the full sustainability report, 3 separate analyses, 1 per campus. That's too much for any single machine, so we mark it decomposable and we let the swarm work out what to do with it. The auction runs and a winner emerges. But this time, the winner doesn't just do the work. It becomes the foreman. It reads the job, sees the seams, and drafts a plan. 3 subtasks and a machine for each. And here's the beautiful part. Those subtasks go straight back onto the auction block, and you can watch them land. 3 child jobs, 3 different machines, 2 continents, all running at the same time. Then the pieces come home. The foreman reassembles them into a single report, and the parent job flips to done. 1 question in, 1 answer out, and in between, a swarm that decided for itself who was cheapest, who was capable, and who was free. A dormitory, a science lab, a corporation with offices on 5 continents. Anywhere idle LLMs sit on a network you control, Krill can find them, price them against the real world, and put them to work together. Thank you, all 1,000 of you, for getting us here. krillswarm.com